So with scale sort of at least under control, I won't say solved, we had to turn to dates, and that was sort of our first little nasty surprise, that the easy date data type stops at 1970, which rules out about 2/3 of my content archive. And so if you go back and use some of the older PHP date functions, they actually have a 32-bit int boundary sometime in 1901. Fortunately, we've got newer datetime classes in PHP, so we developed an extension we call blend archive date, which is essentially just a drop-in data type for the easy datetime object, and uses some of those newer data type fields to give us a longer datetime. Next up was a porous paywall. So how do we both make content restricted for logged out users, but then available for some users as they share it over social networks? And the answer there was a new module that we called shared view, and then we give it a very unique ID. And in this ID is stored the user ID of the user who shared that article and the content object ID that is shared. And so when that unique string is decoded, we know who shared it and we know what they shared, so we can show a customized template that makes that article available, and only that article, and provides a call to action to say, hey, if you like this article, maybe come and subscribe. So on each of our articles, we've got the usual little sharing features there. All of these pass that shared custom URL as opposed to the normal URL for the page. So that drops right into your Facebook feed. Of course, we've got the metadata tags on there to support integration with Facebook. And then when those are shared, we also get a Google Analytics event, so we can say, not only what are the most popular shared articles, but what are the users that are sharing them. So we know sort of who's sharing them, if anybody's abusing the system. It gives us a way to do that. And one of the most fascinating things to me is that in the first month of deployment after this thing launched, the most shared article was actually a first-hand account from somebody that was on the Titanic when it sank, and wrote an article into the Sentinel, which was pretty cool to read. So another big scale problem we had was static assets. So there's a PDF, high-resolution PDF scan of every issue of the magazine, and there is a JPEG of every page on top of the XML, and this totaled about 3 terabytes of data. Now, this is not something I wanted to put inside Easy Publish. I mean, these don't need to be content objects because they're never going to change. They're not indexed by the search engine. But I do want to have some access control around them. I don't want people to be able to download them. It would be nice to be able to use some things like Image Manager to resize them. So the answer here was another module. And we developed what we call the media file module. So I can say media file, and then I have a path here that points to a file in our static archive. If we have that file there and it exists on disk, great, it's returned, no problem. If the file doesn't exist, we have a number of generators. So in the case of this example, I've got a thumb medium, and I've got a thumb generator here that looks for anything with thumb in it. And what that does is it will run this through Easy Image Manager and build that asset. So it assumes anything after the word thumb is a image INI profile. So I'm still able to use profiles and things without having these part of the archive in Easy Publish. Background processing was another interesting problem. So we found very early on that we needed to do some things out of process. We talk to our payment provider when somebody logs in to see if they have an up-to-date subscription. I don't want the user to have to wait for that because it's a bit of a long process. We do things like build PDFs and EPUBs. Those take 30 to 40 seconds to build if they're not existing on disk yet with those media generators. So how do you do things out of process in a clean way? Well, has anybody heard of Gearman? A few people. A lot of people. Good. So Gearman, for those who don't know it, is essentially a way to manage out-of-process functions. So I can register a function in some worker process somewhere, and then call that function remotely, even if it's on another server, and I can have multiple workers. So it was actually developed originally, I believe, by Flickr. So they wanted to resize a bunch of images, but not have you wait on resizing them. And so they have a whole farm of servers that just resize images, and Gearman orchestrates that process. So we incorporated that into Easy Publish, and we wrapped the functionality in what we call a background task. So this is our system for generating PDFs, we have a generate function that basically is supposed to generate a PDF. Now, in our case, this is marked as an asynchronous function, so that media file program that looks for things on disk, when this guy comes back, it says, you know what, I don't have that, I'm not going to have it for a minute. Tell the guy to wait. We call a background task. We say background task instance. We've got a print PDF background task class that actually does the work. We pass it some parameters and we say execute, and we're done. So the rest of this happens on the process. Meanwhile, the user gets a screen like this that just says, hey, hang on, we're getting it. And once that file is generated and saved on disk the first time, then everybody after that just gets the file. So this only happens the first time on a new file. Meanwhile, in the background, where they're looking at that, the print PDF background task just has a function called work, and it receives that the parameters. And I didn't put it all on here, but it basically fires up an Easy Publish template, gets the data out, and then calls XSL FO. So it's doing XSL transformation, which if you've written XSLT, you know that's a lot of fun, but it does work well. So of course, any big site, one of the big problems we have with cache, and Tim Bragg had a pretty good quote from somebody else, said there's only two hard things in computer science: cache and validation, naming things, and off by one error. So we spent a lot of time working with cache, in particular because we had a situation where we had multiple site instances, and then we had another site that had to consume data from these multiple instances. And so we're using a lot of EasyFind and a lot of RSS to do that. And I was actually fortunate enough to go to Lisbon and hear Gil's talk there that I think halved our load time when I got back. So thank you for that, because you saved a life. One of the problems we had is this is our home page, and a lot of this data is queried out of EasyFind. EasyFind is pretty darn fast, even with a large corpus like ours. We get things in about half a second on an EasyFind query. But we've got a lot of half a seconds, and these add up. So we knew that we were going to have to do something extra, in particular on this home page, and there were several aggregator pages like this. We put just these pages behind a varnish cache, and that worked well, but if you hit that varnish cache stale, this thing would be a nightmare. So we didn't want it to go stale necessarily, but we also had the problem of, we can put these in cache blocks, but how do we clear the cache block based on something that happens in another Easy Publish instance? And we came up with kind of a funky little system to do this. So how this works, and we call this one cache keys, is that in our Smart Cache, our View Cache INI, into the Smart View Cache section, so for an audio program, which is one of our class types, I have this key here for journal audio program. We have a workflow event that when that is published, we'll update that key in a table that all of the instances can see with a hash of the microtime. So you get a unique value essentially every time you update that. And so we have a table with about 15-20 rows in it that puts that together. And then we wrote a fetch that retrieves that data. And the way the fetch does it is by doing one SQL query select star on that table. It's a very small table. And then once we have it in memory, we hold on to it and don't let it out again. So we only ever have to make this call once per request. So we had to add a SQL request, but it's only one, at least when it's a small one. And what that allows us to do is completely shut off expiry on these cache blocks and just set the data based on what is in the block. So if this particular cache block pulled the latest audio program and audio event from the journal and Sentinel, and so it has those 4 keys used as its key there. So that really simplified the use of keys, because we didn't have to come up with, you know, some new clever way to get the data all the time. We just sort of named the things we wanted to look for, so it's almost an event model. Finally, a little about hosting architecture. I don't think we're doing anything particularly unique here, but we are hosted out on Amazon, so we're using Elastic Load Balancer. We are currently using NFS, but we're likely going to switch to Gluster for redundancy very soon. Hopefully, we're going to archive some of our data since we're still using that full 3 terabytes, even though we don't always need the full 3 terabytes online. So archive some of that to S3. And we're using RDS for the database, so we've got a nice redundant replication solution there. So it's fully redundant is the idea there, so that we, even if Amazon's having a bad hair day, hopefully can stay up with very little downtime. So that's sort of the long and short of it. I've kind of given you the vegetables and the dessert there. Any questions I can answer? All right, well, we'll just head out for lunch early then. My contact info is up there, and thanks for your time.
Thanks a million, Joe. Super interesting. Yeah, that's very, very good reflection. Please use that. That's useful to give feedback to speakers, so they can improve and keep that approach. We have lunch now, as yesterday, across the lobby, same floor, and we resume at 1400 back here with the end of the session.